In this lesson, I'll show you how to set up and solve quadratic word problems. This is part 1. The first question reads, the angle iron shown in the figure below has a cross-sectional area of 53.4 centimeters squared. Find the thickness of x. I want to draw your attention to this diagram. Notice that we have two rectangles. This is considered a composite figure, which is a shape composed of two different shapes. In our case, we have a rectangle positioned this way and a rectangle positioned this way. We are looking for the thickness of both of these rectangles. Notice that they're both denoted with the letter x. We're told the area of the cross section, it's 53.4. So what we have to do is find the area of this one, the area of this one, add them up, and that will equal to 53.4. So I'll call the area of this rectangle number 1, and I'll call the area of this rectangle number 2. So we have 1 plus 2 is equal to 53.4. Let's try to find the area of rectangle 1. Remember that a rectangle, its area is length times width. Let's write that down. Length times width. The length of this rectangle, if we were to cut it from here, is 15.6 minus what we cut, because 15.6 is the length from here all the way to here, and if we take away x, we have 15.6 minus x, that's the length, times the width is x. Let's try to do the same thing for this rectangle. This time the length is 10.4 plus 10.4 times the width of x. That is equal to 53.4. Next, I'll expand this expression. We end up with 15.6 x minus x squared plus 10.4x, and at the same time I'm going to bring this number over here because I want to solve for x. I need to set one of the sides equal to 0. So by bringing 53.4 over to the other side, it becomes negative 53.4 is equal to 0. And as you can tell, we have a quadratic equation. We have this term right here, which is a second degree term, and therefore we're dealing with quadratics. So I'll rewrite this and I'll collect like terms. This term and this term are alike. We have negative x squared plus 15.6 plus 10.4 is equal to 26.0x minus 53.4 is equal to 0. The whole purpose behind this series of videos is to show you how to set up and then solve. So I've set up my equation. Now it's up to you to solve it. And of course, you would need to use the quadratic formula from here. You can use the quadratic formula manually, but I choose to use the one that's on my calculator. And to access it on my calculator, you click Mode, 5 for equation, and 3 for quadratics. You substitute your coefficients into here. Negative 1 for my A term coefficient, 26, and minus 53. I end up with one of my answers as 23.7 and another answer as 2.22. Let's write them both down. Which of these makes more sense? Now, of course, it can't be 23.7 because take a look at the diagram here. If this is 23.7, that exceeds 15.6, which is much longer. Therefore, this is my only solution, and we can discard this one. Let's move on to question number 2. Question number 2 is equal in difficulty to question number 1. It reads, one leg of a right triangle is 3 centimeters greater than the other leg and the hypotenuse is 15 centimeters. Find the legs of the triangle. The legs of the triangle are the sides that are not the hypotenuse. So this is considered a leg and this one's considered a leg. The hypotenuse we know is 15 centimeters. The area that binds all of these three sides together is the Pythagorean theorem. So we'll use the Pythagorean theorem to find our answer. The Pythagorean theorem is a squared plus b squared is equal to c squared, and at this point we can replace c with 15, and 15 to the power of 2 is 225. Now we're told that one of the legs is 3 centimeters greater than the other. So what I'll say is that a is 3 centimeters larger than b. And I'll substitute this into my a value, and I'll leave b the way it is. So I'll have an equation that's exclusively in terms of b. So substituting 3 plus b into a, and remember that's being squared, plus b squared, This right here is a binomial. We need to expand that. So we have 3 plus b, 3 plus b. 3 times 3 is 9, plus 3b, plus 3b, plus b squared. Now, of course, your teacher might want you to label what a and b are. So you can say that a is the longer of the legs and b is the shorter one. And you can write that down as a legend. These two terms become 6b, and we have b squared plus 6b plus 9 plus b squared is equal to 225. This is a quadratic equation. In fact, we can combine these. We end up with 2b squared plus 6b plus 9. And I can take this term over to the other side because I want to solve for b. As you can see, 9 and negative 225 can be combined as well. That becomes negative 216, 6b plus 2b squared. We have set up our equation. Now all we have to do is find out values of b. Let's use our calculator again for the quadratic formula. 2, 6, and negative 216. We end up with the answer 9 and the answer negative 12. Of course, we're going to disregard negative 12 and use 9 only, because generally you can't have a negative length. So b is equal to 9, and our longer side, a, is equal to 12 because you substitute 9 back into here and you end up with 12. And there you have it. 2 examples on how to set up and solve quadratic word problems.